Today we're going to talk about exponents. And what an exponent does is it indicates how many times a factor is multiplied by itself. And what that means, we know if we have something like 5 times 3 equals 15, 5 is a factor, 3 is a factor, and 15 is called the product. And this is just multiplication. Now, exponents is a different type of multiplication. If we have the following, 5 to the third power, all right, or the power of 3, this number 5 is called the base. This 3 is your exponent, all right? And the way we would read this number, we would say 5 to the power of 3, or 5 to the third power. All right? So just a new type of language with some multiplication. Now this does not mean 5 times 3. What this really means is I'm taking that factor of 5 and I'm multiplying it by itself 3 times. So the exponent tells me how many times or how many of these factors of the same factor I'm going to have. When I actually simplify or multiply this out, 5 times 5 is 25. I'm going to bring this 5 down, and 25 times 5 is 125. So 5 to the third power, when simplified, is 125. All right? So see how this is different from basic multiplication. All right? Now, we have some more vocabulary, and you want to be familiar with this. And we can write these numbers in exponent form, expanded form, and standard form. So, just like the word exponent, it's going to have the exponent written there. So 5 to the third in exponent form would look like this. In expanded form, this would be 5 times 5 times 5. Standard form is when you've actually simplified it or multiplied it out. So in standard form, that would be 125. And these are all equal to each other. They have the same value. Now, we have some, let's say we had 5 to the fourth power, 5 to the third, 5 to the second, 5 to the first, and we're going to look at 5 to the power of 0. So 5 to the fourth means 5 times 5 times 5 times 5. 5 to the third means 5 times 5 times 5. And we follow the pattern. So this is a little bit interesting. Now, if we have 5 to the fourth, all right, this is really 625. 5 to the fifth, when simplified, is 125. 5 squared, or 5 to the second power, is 25. 5 to the first is just 5. That exponent of 1 tells me I just have that factor one time. So, what would 5 to the 0 power be? Well, let's look what's happening. How do I get from 625 to 125? I'm dividing by 5. What happens to get from 125 to 25? Again, I'm dividing by 5. To get from 25 to 5, I'm dividing by 5. So if I continue the pattern and I divide by 5, 5 divided by 5 is 1. Isn't that interesting? 5 to the 0 power equals 1. Something you have to memorize, that any number to the power of 0 equals 1. Alright, so that's just something you have to memorize. Don't forget. So 6 to the 0 power would equal 1. 3 to the 0 power would be 1. What about 1 to the 0 power? That would still be 1, all right? And a lot of people like to ask, well, what would 0 to the 0 power be? Well, that's what we call undefined, all right? We just don't worry about that one. Now, we have some special exponents. And the first special exponent is the 2. In math, we use this exponent of 2 very, very often, and so this gets a special name. And the way we would read this would be n squared. We are squaring n. That means that we are just doing n times 2. There are 2 of them. When we have an exponent of 3, that is what we would say. We would read that as n cubed. So we would have 3 n's. So we do see that quite a bit in math. So if we had 12 squared, we know that's 12 times 12, which is 144. So we just want to be familiar with that special exponent. All right. Another thing we want to talk about are some exponents with what we call the base 10. So if our base is 10, let's take a look at some of these numbers. You're going to like this. If we have 10 to the 5th, 10 to the 4th, 10 to the 3rd, 10 to the 2nd, or we could say 10 squared, 10 to the 1st, and 10 to the 0 power, we know that this means I have 5 tens. 10 to the 4th means I'm multiplying 10 4 times. 10 cubed means 3 tens. 10 squared would be 2. That would be 1. We already said anything to the 0 power is equal to 1. So we know that's a 1. Now what's kind of nice about having this base 10 is if we need to write this and simplify, solve what this really is, we don't need to get out our calculator. If I look at this exponent matches how many zeros? Exponent of 5, and notice I have 1, 2, 3, 4, 5. And so when we simplify this, this is just going to have 1, 2, 3, 4, 5 zeros. 10 to the 4th, the 4, look at that, 1, 2, 3, 4. It's just going to have 4 zeros. 10 to the 3rd, we'll have 1, 2, 3 zeros. 10 squared, we'll have 2 zeros. 10 to the 1st will have 1 0, and 10 to the 0 is just 1 0. So when you're simplifying or evaluating to find the value of 10 to the 5th or 10 to the 4th, it's just going to have that number of zeros. So if we had the following, and we wanted to solve for n, in other words, what exponent is n, what we'd really have to do, very simply, is just go back and look at these zeros. I have 1, 2, 3, 4, 5, 6, 7, so the exponent would have been a 7. If I had the following, equals 10 to the power of n, and we have 1, 2, 3, 4, so n would be equal to 4. So, just want to say thanks for checking in with us. Hope the notes were helpful, and we'll catch you next time.